Alrighty.
You take your earbuds out.
Intercept form. Last of three forms. Last of three forms. I think intercept form is probably the rarest form you will see. It does not come up a lot, but it is something that you will see later down the road when we start factoring. So this is the last of the three you need to know. And just a heads up, this week we are finishing our intercept form notes. Tomorrow you will work on your intercept form practice. And then the rest of the week, you are finishing the entire packet by Friday, as well as we are giving you a half sheet, half cardstock that you will be able to put anything you want on front and back to use for the test on Friday. Okay? So if you need to write down tricks, oh, you're good. If you need to write down tricks for calculators, written out steps for each forms, that's something you want to start thinking about. So intercept form is y equals a times x minus p, x minus q. X minus p, x minus q. So you will notice we have three values, which will be extremely helpful. It has that a value that all the other two forms have. Only instead of HK, instead of BC, we have a P value and a Q value. One way we know that this is intercept form is, first, there are no exponents. Do you see any exponents? There are no exponents. And instead of one set of parentheses like in vertex form, two sets of parentheses. Okay, that is how you can identify intercept form. There are no exponents. It has parentheses like vertex form, but this one has two sets of parentheses. Okay, so that is how you can tell this is intercept form. Okay, A, P, and Q, just like before, we are finding our same things. We're finding that vertex, that tippity top or very bottom of our valley. We're finding our axis of symmetry. We're going to use our calculators to create a table, and then we're going to graph each one. Okay? So A, P, and Q. First off, whenever you have a negative floating out in front of parentheses, what number is actually there? A -1. So if you're freaking out like, oh my gosh, what is it? I don't have an A value. Just put a 1 out there. Our A value is -1, that number floating out front, -1. Just like before, our A value is really just there to help us determine if our graph is going to be a maximum or minimum. If it's going to point up like a smile or down like a frown. P value is our next value, our first value in parentheses. And if you remember in vertex form, we always had to flip the H value. Remember that? We'd always flip the number inside parentheses. For P and Q, the same thing. Numbers inside of parentheses, when you're writing down their value, have to be the opposite of what they look like. So instead of 5 for P, we'll write -5, opposite sign. Instead of +1, we flip the sign, -1. Okay, if they were already minus, we would flip them to positive. That is your A value, your P value, and your Q value. A, P, and Q. Okay. Once you have your A, P, and Q value, your values, it's the values that help us figure out the rest of the info so we can get to our graph. So our first step is finding the vertex. And again, this is not vertex form, so we can't just look at our equation and know what our vertex is just by looking at it. We have to do a little bit of extra work. Most important info on this page is right here. X equals P plus Q divided by 2. P plus Q divided by 2. That formula comes from finding the average. Okay, my P value is over here, my Q value is over here. I know that the vertex has to be right in the middle. So to find what's right in the middle of numbers, you add them together and divide. Okay? So we're going to add our P plus Q and divide by 2. So I'm plugging my numbers in for P and Q exactly how they look. P is -5 plus Q, which is -1, divided by 2. This is my X value. P plus Q divided by 2. Put in P, put in Q, divide by 2. We didn't even use our A value. So in our calculator, how would we plug this in? Well, we type in P plus Q, -5 plus -1, and hit enter. We add the tops. We get -6 over 2. And then we divide it by 2. And we get -3. That is my vertex. -3.
So is the -1 came from the P, right? From the top?
Yep, the -5 and -1 came from those numbers in the parentheses.
Yeah, and which is it came right there, right?
Yep. Add them together, divide them by 2, and you have your X value. Now, just like standard form, remember, that only gave us half the vertex. We know it's at -3 on the x-axis, but we don't know how far up or down it is. So we need to find this number. Now, remember, one method is you could always plug -3 back into your original equation, but that's a lot of work and requires a lot more algebra. Our second option is we can go put our equation into our table, our graph, and find our table, and then look it up. And I'm going to show you even a third way to do it today. So click on y equals. We have to tell our calculator what equation we're using, so we're going to type this in. You can put the invisible one or not put the invisible one. It's up to you. I feel like not putting it in. So negative parenthesis x plus 5 parenthesis, another set of parentheses, x plus 1. Make sure that the sign out in front, you use the negative button in your calculator, not the minus. Remember, if you're ever putting things in your calculator and it gives you an error, you probably mixed up the minuses and the negatives. So just always double check that. You can't see it, but I have a negative out front. Once you have everything in, we are going to go to our table, find -3 in our table, and we'll be able to find the y value that matches up with it. So second graph goes to my table. I am looking for the x value, first column. I'm looking for -3. And there it is, right there, -3. The number that goes with it is 4. So 4 is the y value of my vertex. And now I have my whole vertex. It's at the point -3, 4. Just to show you one more way. So you'll have 3 ways to do it. You can plug it in to the original equation. That probably takes the most time. You can type it into your y equals and go to your table and look for it. You can even click this graph button, and we can get a sneak peek of what our graph will look like. That's what our graph should look like at the end. Now, if I press trace, which is this button right next to the graphing button, I'll see a little spider pop up on my graph, which you can move back and forth. And then you're going to type in your x value. Our x value is -3. Type in -3 and click enter. That is another way you can do it. What point does it give us? -3 and 4. That is a third way you can find that y value. Okay, I'm not going to tell you which way you have to use. Okay? Any of those three ways will work. So I'm going to go back to my table. Okay? We got our vertex, which means we know what our axis of symmetry is. Because if you remember from last week, our axis of symmetry will always go through the vertex. And it's a vertical line, and will go through the x value. So the number we found in our equation, -3, that's our axis of symmetry. It'll always be like that. X equals -3. The first number of your vertex for every problem, no matter what form it's in, that first number in the vertex is always the axis of symmetry. Okay? So if you find the vertex, the axis of symmetry should be a freebie. It's the same as the x value every time. Okay? So we got vertex, we got axis of symmetry. Now it's time to decide, is this a maximum or a minimum? Well, we saw the graph a second ago. But if I look at my A value, it's a -1. Negative means we're having a bad day and we have a frown on our face. And frowny faces always have a maximum at the top. You can always, too, if you click that graph button, you can look at what your graph's going to look like. You can tell it's going to be a maximum. And finally, it's time to put our vertex in the center of our table. Our vertex is the point -3, 4, right in the middle. Right in the middle. Once it's there in the middle, we can go look at our table and copy down the rest. So 2 good points above, two good points below. -4, 3. -5, 0. -2, 3. -1, 0. And remember, you should always see symmetry. On the right side, we have the 4 in the middle, the vertex. Then we got 3s. Then we got 0s. Next, we would have -5s according to our table. Then -12s. You should see symmetry on the y value. Now it is just time to plot these points and connect their dots. -3 to the left, up 4. There's our vertex. That's the center of our quadratic. Our axis of symmetry goes through that and cuts our graph in half. We have -4, +3. Since that point's there and the vertex is in the middle, then I know this also must be a point because our graph must be symmetrical. Then I have -5, 0. Over 5 to the left, 0. If there's a point there, there must be a point here. Quadratics are always symmetrical. Okay, which that works. That's the point -1, 0. This is the point -2, 3. We have symmetry, which means our table is correct. We put everything in correct. Our vertex was correct. It's time to plot our points and connect them. There's our quadratic. You can even go ahead and click on the graph button and double check. Look, yes, that does look very similar. Of course, we're graphing by hand, so mine's a little off. But that's the gist of that. How was that? That's the last form, intercept form. Not too bad. Okay, 2 examples, and then we're done for today. Go ahead and flip the page, and you should look at something like this. You can go to the y equals in your calculator and clear that out. We won't be needing that anymore. All right, example 2. We're doing the same exact thing. A, P, and Q. We know this is vertex form because what does it have? What doesn't it have? There's no exponents and there are 2 parentheses. Exactly. Intercept form. Okay. We also have that invisible 1 is back, so we're going to put that little invisible 1 in, -1. And we're going to start off by identifying A, P, and Q. A, P, and Q. My A value appears to be -1, I agree. My P value, what is it? -1, good. We flip the sign, it looks like +1, we flip it to -1. And my Q value, +1. Looks like -1, flip it to +1. There we go, A, P, and Q. If it were vertex form, I could just go ahead and find my vertex right now just by looking at my values. But intercept form, we need that equation, P plus Q divided by 2. P plus Q divided by 2. This finds me my axis of symmetry, and it finds me half of the vertex. So let's add P and Q. -1 plus 1 divided by 2. -1 plus 1 equals 0. 0 divided by 2 is definitely 0. So our vertex, the beginning of it is the point 0 something. We also know our axis of symmetry is the line x equals 0. Both of those are found once you do that P plus Q divided by 2. Again, the issue with vertex form and intercept form and standard form is we only get half the vertex. It is our job to find the other half, which means it's time to go over to our calculators and start plugging in our original equation. -1, again, you can put the 1 or you can leave it out. This time I'll put it. -1, x plus 1, x minus 1. If you ever get an error here, you probably mixed up your minuses and your negatives.
It will go 0.
Yep, if we go to our table, second graph, we need to go find 0. What number goes with 0? 1. That is our vertex, the point 0, 1. See how the 1 is with the 0, 0, 1? 0, 1.
And mine just says 0, 0.
If you do not have 0, 1, maybe we put in something weird. This does definitely say 0, 0. Is this, that's a -1? It should be Yep. It is so sensitive about minuses and negatives. Remember, the second thing you could have done is you could have gone and looked at your graph. Once you're at your graph and you give it a second to draw, you can always click trace, enter in your x value you found, which was 0, and click enter, and it'll also give you 0, 1. 2 different ways you could do it.
How about the chart?
Oh yeah, so let's do the chart. We need our table. So our vertex goes right in the center of our table, 0, 1. And now we go to our table and we copy 2 nice points above, 2 nice points below. We got -1, 0. We got -2, -3. And we do the same below. 1, 0, 2, -3. Always making sure we check that symmetry in the y. Quadratics are symmetrical. If the numbers aren't the same on the y side, then your graph is not correct. It needs to be symmetrical. Quadratics are always symmetrical. I always start by graphing my vertex. 0, 1. Then I work my way up. -1, 0. -2, -3. Okay? If those are my 2 points on the left side, the ones on the right side of the dot should be exactly the same. So if I had to guess, they would be right here, since quadratics have to be symmetrical. We can check. 1, 0, that works. 2, -3, that matches up. Symmetrical quadratic. Draw your arrows and connect your dots. The only thing we did not do yet is max or min. Looking at our graph, does this have a maximum or a minimum? This is our vertex way up here. Is that at the top or the bottom? The top of the hill, so it's a max. Example 2, finished. On to example 3. In example 3, again, we have intercept form. Because there's no exponent, and we have 2 sets of parentheses. In example 3, it looks like there's no a value to be found. I don't see anything in front of that parenthesis. Don't think it's 0. It is a 1. If there is no a value to be found, it is 1. Okay, let's do it. A, P, Q. A, P, Q. We talked about our a value has to be 1. There was nothing out there. It's invisible, so invisible 1. Don't forget, any value that is in parentheses, their sign must be flipped. Instead of positive 3 for P, it is negative 3. Instead of negative 1 or minus 1 for Q, we flip it to positive 1. There's my A value, my P value, and my Q value. And again, we run into the same situation where I need a way to find my vertex, and that is P plus Q divided by 2. Negative 3 plus 1 divided by 2. Add my top, negative 3 plus 1. My top simplifies into negative 2. My bottom is still 2. And all I need to do is divide by 2. Oop, I did plus. Oh, no, I did. My answer is negative 1. We just found the half of our vertex, negative 1 comma something, and my axis of symmetry is negative 1.
You might want to change that Q to a negative 1.
Which one?
The one near the Q.
The Q?
Yeah.
The Q is a positive 1 because remember it flips.
Oh.
Any value that's ever inside parentheses, we have to flip its sign.
I was just confused because it's like the AOS vertex. It's like negative 1.
Oh yeah, the x value is negative 1, and that came from the p plus q over 2. It did not come from the a, p, or q value. I had to find that separate. That's a good question though. Okay, we're at this part now where we're stuck. So we need to go to y equals, clear out that old graph, and we need to put in our new graph. You can put the invisible 1 or not. It is up to you. I'm not going to put it. X plus 3, x minus 1. That's my entire equation. X plus 3, x minus 1. Get it into y equals, and remember, we have 3 ways to do this. We could take negative 1 and plug it back into the equation and do a bunch of algebra to simplify. We can go to our table and find negative 1. Or we can go to our graph and type in negative 1. Lots of different ways we can do it. So I'm going to my table, and I'm looking for negative 1. Negative 1 goes with negative 4. Okay, we can also go to the graph, click trace.
Right, you okay?
and type in -1 and click enter. Another way you could have done it. Again, lots of ways you can find that y value. You can do any. Okay, I don't have a table. I need a table, so create a table.
If you guys need to step out, you're more than welcome.
Okay, put your vertex right in the center. 1, -4.
Okay.
Copy down your table. -2, -3. Oh, did I go to the wrong place? No, I just forgot to write my negative. -2, -3. -3, 0. Same underneath.
0 -3.
And 1,
That was it.
0. Beautiful. Plot your points, connect your dots, and we're finished. After we determine max or min. So, -1, -4. -2, -3. And -3, 0. We got 0, -3. Smart board's starting to lag. And 1, 0. Connect your dots.
All things considered. Big breath.
Looking at my quadratic, I can tell my vertex is way down here at the bottom. So it's going to be a minimum. You also know that because my A value was a +1. Positive means smiley face. This does look like a smiley. Smileys have minimums. That is an intercept form. The only difference from standard form is instead of -b/2a, we use p + q divided by 2. Otherwise, it's the same.